There have been reports of CH breakers switching themselves to the off position. While this is uncommon, these incidents have been reported by qualified electricians and are currently under investigation. The exact cause of this issue is still under investigation, but potential factors include: firstly, electrical faults within the breaker mechanism; secondly, loose or faulty wiring connections; thirdly, electromagnetic interference from external sources; and fourthly, corrosion or damage to the breaker components. CH Electrical is aware of these reports and is taking the following actions: firstly, investigating the issue in cooperation with the affected customers; secondly, replacing or repairing affected breakers; and thirdly, conducting additional testing to determine the root cause. While the issue is being investigated, it is prudent to take the following precautions: firstly, inspect CH breakers for any loose connections or visible damage; secondly, regularly monitor electrical panels for any unusual behavior; and thirdly, if a CH breaker switches itself off unexpectedly, do not attempt to reset it immediately. Contact a qualified electrician to investigate the issue. The issue appears to be limited to specific models of CH breakers. Not all CH breakers are affected. CH Electrical is cooperating with independent testing laboratories to verify the issue and determine a solution. While the issue of CH breakers switching themselves to off is not widespread, it is important to be aware of the potential problem. If this issue is experienced or there are any concerns, contact CH Electrical or a qualified electrician for assistance. It is important to understand how a circuit breaker is designed to function. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then has to be replaced, a circuit breaker can be reset either manually or automatically to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect high-voltage circuits feeding an entire city. Circuit breakers are essential components in electrical systems, ensuring safety and preventing damage from overcurrents. There are several types of circuit breakers, each designed for specific applications and operating principles. Firstly, thermal circuit breakers; secondly, magnetic circuit breakers; and thirdly, solid-state circuit breakers. Thermal circuit breakers operate on the principle of thermal expansion. They contain a bimetallic strip that heats up and bends when an overcurrent occurs. The bending of the strip triggers the tripping mechanism, opening the circuit. Thermal breakers are commonly used in household appliances and low-voltage applications. Magnetic circuit breakers use an electromagnet to detect overcurrents. When the current exceeds a predetermined level, the magnetic field generated by the electromagnet becomes strong enough to trip the breaker. Magnetic breakers are faster acting than thermal breakers and are often used in applications where quick response to faults is critical, such as in industrial equipment. Solid-state circuit breakers, also known as electronic circuit breakers, use electronic components to detect and interrupt overcurrents. These breakers offer precise and fast protection and can be programmed to respond to various fault conditions. Solid-state breakers are used in advanced power systems and critical applications where reliability and performance are paramount. The basic components of a circuit breaker include: firstly, contacts; secondly, a tripping mechanism; thirdly, an arc chute; and fourthly, an operating handle. Contacts are the conductive parts of the breaker that make and break the electrical circuit. They are typically made of a highly conductive material such as copper or silver alloy to minimize resistance and heat generation. The tripping mechanism is the heart of the circuit breaker. It senses overcurrent conditions and initiates the tripping action. The tripping mechanism can be thermal, magnetic, or electronic, depending on the type of breaker. An arc chute is a structure designed to extinguish the electric arc that forms when the breaker contacts open under load. The arc chute helps to cool and dissipate the arc, preventing damage to the breaker and surrounding equipment. The operating handle is used to manually switch the breaker on and off. It also indicates the status of the breaker, whether it is on, off, or tripped. The handle provides a means for resetting the breaker after a fault. The operating principle of a circuit breaker involves several steps. Firstly, normal operation. Secondly, overcurrent detection. Thirdly, tripping action. And fourthly, arc extinction. During normal operation, the breaker contacts are closed, allowing current to flow through the circuit. The tripping mechanism is in a standby state, ready to respond to any overcurrent conditions. When an overcurrent occurs, a tripping mechanism detects the excessive current flow. In a thermal breaker, the bimetallic strip heats up and bends. In a magnetic breaker, the electromagnet generates a strong magnetic field. In a solid-state breaker, electronic sensors detect the overcurrent. Once the overcurrent is detected, the tripping mechanism initiates the tripping action. This involves releasing a latch that holds the contacts closed. The contacts quickly separate, interrupting the current flow and opening the circuit. As the contacts separate, an electric arc forms between them. The arc chute helps to extinguish the arc by cooling it and dissipating the ionized gases. This prevents the arc from damaging the breaker and causing a fire. Circuit breakers offer several advantages over fuses. Firstly, resettable. Secondly, reliable. And thirdly, safe. Unlike fuses, circuit breakers can be reset after a fault, saving time and money. Circuit breakers are designed to provide reliable protection over many years of operation. They are less prone to nuisance tripping than fuses. Circuit breakers provide a safe means of disconnecting power in the event of a fault. They minimize the risk of electric shock and fire. When selecting a circuit breaker, several factors should be considered. Firstly, voltage rating. Secondly, current rating. Thirdly, interrupting capacity. And fourthly, application. The voltage rating of the breaker must be equal to or greater than the voltage of the circuit it is protecting. The current rating of the breaker must be matched to the load requirements of the circuit. It should be high enough to handle normal operating currents but low enough to trip in the event of an overcurrent. The interrupting capacity of the breaker is the maximum fault current that it can safely interrupt. It must be high enough to handle the potential fault currents at the installation location. The application of the breaker will determine the type of breaker needed. For example, a residential circuit will typically use thermal breakers, while an industrial application may require magnetic or solid-state breakers. Proper installation and maintenance are essential for ensuring the reliable operation of circuit breakers. Circuit breakers should be installed by qualified electricians in accordance with applicable electrical codes. Regular inspection and testing should be performed to identify any signs of damage or wear. Circuit breakers should be kept clean and free from moisture and corrosion. Troubleshooting circuit breaker problems involves several steps. Firstly, visual inspection. Secondly, testing. And thirdly, replacement. Start by visually inspecting the breaker for any signs of damage such as cracks, burns, or loose connections. Use a multimeter to test the breaker for continuity and proper operation. If the breaker is faulty, it should be replaced with a new breaker of the same type and rating. Several common problems can occur with circuit breakers. Firstly, nuisance tripping. Secondly, failure to trip. And thirdly, overheating. Nuisance tripping occurs when a breaker trips for no apparent reason. This can be caused by a faulty breaker, loose connections, or electromagnetic interference. Failure to trip occurs when a breaker fails to trip in response to an overcurrent. This can be caused by a defective tripping mechanism or a breaker that is too large for the circuit. Overheating occurs when a breaker gets too hot during normal operation. This can be caused by a loose connection, an overloaded circuit, or a faulty breaker. In conclusion, circuit breakers are critical components in electrical systems, providing essential protection against overcurrents and short circuits. Understanding the different types of breakers, their operating principles, and proper selection, installation, and maintenance practices is crucial for ensuring electrical safety and preventing damage to equipment. Regular inspection and testing can help identify and address potential problems before they lead to more serious issues. If you encounter any problems with your circuit breakers, consult a qualified electrician for assistance. Consider the environment where the circuit breakers are installed. High humidity or corrosive environments can accelerate the degradation of breaker components. In such cases, consider using breakers specifically designed for harsh environments or implementing protective measures to mitigate the effects of environmental factors. Ensure that the electrical panel is properly grounded. Grounding provides a path for fault currents to flow back to the source, helping to trip the circuit breaker and clear the fault. A properly grounded system enhances safety and reduces the risk of electrical shock. Regularly check the tightness of connections within the electrical panel. Loose connections can cause resistance, leading to heat buildup and potential breaker failure. Use a torque wrench to tighten connections to the manufacturer's specifications. When replacing a circuit breaker, always de-energize the circuit first. Turn off the main breaker or disconnect the power supply to the panel before removing or installing any breakers. This prevents the risk of electric shock and ensures your safety. Label all circuit breakers clearly and accurately. Proper labeling makes it easy to identify the correct breaker for each circuit, simplifying troubleshooting and maintenance. Use a circuit directory or label maker to create clear and legible labels. Keep the electrical panel clean and free from obstructions. Dust, dirt, and debris can accumulate inside the panel, reducing ventilation and potentially causing overheating. Regularly clean the panel with a vacuum cleaner or soft brush. Consider using surge protection devices to protect sensitive electronic equipment from voltage spikes and surges. Surge protection devices can help prevent damage to appliances, computers, and other electronic devices caused by lightning strikes or power surges. Be aware of the signs of an overloaded circuit. These signs may include flickering lights, warm outlets, and frequently tripping breakers. If you notice any of these signs, reduce the load in the circuit or consult an electrician to upgrade the wiring. Educate yourself and others about electrical safety practices. Share your knowledge with family members, coworkers, and friends to promote a culture of safety and prevent electrical accidents. If you are unsure about any aspect of electrical work, always seek the help of a qualified electrician. Working with electricity can be dangerous, and it is best to leave complex or unfamiliar tasks to professionals. Stay updated on the latest electrical codes and standards. Electrical codes are constantly evolving to reflect new technologies and safety practices. Familiarize yourself with current codes in your area to ensure that your electrical system is up to date and compliant. Consider using arc fault circuit interrupters, or RFIs, in your home. RFIs are designed to detect and interrupt arc faults, which are a common cause of electrical fires. They provide an extra layer of protection beyond traditional circuit breakers. Use ground fault circuit interrupters, or GFCIs, in wet or damp locations. GFCIs are designed to protect against electrical shock by detecting ground faults. They are commonly used in bathrooms, kitchens, and outdoor areas. Ensure that all electrical equipment is properly grounded. Grounding provides a path for fault currents to flow back to the source, helping to trip the circuit breaker and prevent electrical shock. Use 3-prong plugs and outlets for all grounded equipment. Avoid overloading extension cords or power strips. Overloading can cause overheating and increase the risk of fire. Use power strips with built-in circuit breakers to protect against overcurrents. Inspect extension cords regularly for damage. Replace any cords that are frayed, cracked, or have exposed wires. Never run extension cords under rugs or carpets. This can trap heat and increase the risk of fire. Keep electrical cords away from water. Water is a conductor of electricity, and contact with water can cause electrical shock. Use caution when working near water and keep electrical equipment dry. Be aware of the location of underground utilities before digging. Contact your local utility company to locate underground lines before you start any digging project. This prevents damage to underground cables and ensures your safety. Use caution when working near overhead power lines. Maintain a safe distance from power lines to avoid electrical shock. If you are working with long objects, such as ladders or tree branches, be aware of the potential for contact with overhead lines. If you see a downed power line, stay away and call your local utility company immediately. Do not touch the line or anything in contact with it. Treat all power lines as if they are energized.